So 7-1 is going to be the beginning of your Chapter 7 test. It is going to be a review of concepts mostly from your Algebra 1 class. You will have a few things in here that will be geometry related, but this is more of an intro and review of things that you're going to be using as we go forward. So make sure you complete these notes, and if you have any questions, you can ask them when we get started on our assignment tomorrow. We will not have an assignment on 7-1 until the next time that we come in. So starting off with a ratio. A ratio is going to be a comparison of two numbers by division. You can write that one of three ways. You can write it with the 5 to 7 with the word 2 in the middle between it. You can write it with the colon in between it, which is going to be this one right here where it's 5 to 7. You see that actually when people are giving odds of something happening. They use that in betting and all kinds of other places, like at the racetrack. That's going to be on the racing pole. You're going to have it written mostly as fractions in this class, so you will see them mostly as fractions in here. The first number goes on top, the second number goes on bottom. Now when you see them and you have a ratio of numbers like this one, if you have 20 sophomores, 5 juniors, and 4 seniors, and you want a ratio of the sophomores to the juniors, you would put sophomores on top and juniors on the bottom, like 20 over 5. It does need to be simplified, but you have to remember this is a ratio, not just a fraction. And ratios will always say a comparison of two numbers. So when you write it, you still leave it as 4 over 1. Now, the one that comes first needs to come first in your ratio or on the top. So even though these are the same things, juniors to seniors and seniors to juniors, they are written very differently. If it's juniors to seniors, there were 5 juniors, so that would go on top, and 4 seniors, so that would go on the bottom. Seniors to juniors would go 4 over 5. Those are very different numbers, guys. 5 over 4 is equal to 1.2. 4 over 5 is equal to 0.8. 1.25 if you want the actual number for it. So when you look at these are very different amounts. Because of that, the way you write them is very important. Now, I put a little star next to this one, and I put this one on here because in geometry you get a couple of weird things. Every once in a while you'll get one where they give you two different types of measurements. You get units that are like inches and feet. If you get that, you have to convert to a common unit. You'll always want to go to the smaller of the units because it's easy to multiply and get there. So we take this 2 feet that's going to be over here on this one right here. We would take 2 feet and multiply it by 12 because there are 12 inches in every foot, and find out that we have a total of 24 inches. So what we're really comparing is going to be a comparison of that 10 inches to the 24 inches. And if you compare 10 to 24, that would reduce down, which you can reduce using your calculator, to 5 over 12. 5 over 12. And remember, always reduce your ratios. So from there, the next thing we're going to talk about is what we call extended ratios. Extended ratios are going to be a comparison of 3 or more numbers. Guys, the difference is that when you write an extended ratio, you will be writing them in this colon format. So you'll see them written A to B to C, like 1 to 2 to 3. So when you have this, you're going to use this in an application problem for geometry. It says the ratio of 3 sides of a triangle is 5 to 12 to 13. And the perimeter is 90. Now remember, when you're doing perimeter is just all 3 sides added up. So you can see that we have a line for each one of these. We have a line that represents side 1 right here, side 2 right here, and side 3 right here. We're setting up a ratio that is an extended ratio with the 5, the 12, and the 13, but we're putting them all multiplied by the same exact variable, and you'll use the same one every time when you're doing that. So it's 5x plus 12x plus 13x equals our perimeter of 90. We would combine like terms. 5x plus 12x plus 13x is 30x equals 90. When you solve for x, you divide by 30, that gives you x equals 3. Now, guys, they're looking for the lengths of the three sides, not what x is. To find the lengths of the three sides, you've got to plug it back in. So when you plug that back in, you're plugging in and doing 5 times 3 to get you 15 for the first one. 12 times 3 gives you 36 for the second one. And 13 times 3 gives you 39 for the last one, which if you add them all up, that'll give you your perimeter of 90. You're going to see those extended ratios being used as we go forward throughout this chapter. So that's something you definitely need to be able to apply. Now, the next thing we're going to see is proportions. Guys, this is some vocabulary that you're going to be like, oh, no big deal. And I'm telling you right now, there is something called the geometric mean. And knowing what the parts of a proportion are called is a big deal. You've done proportions before, but you've never had this vocab. So a proportion is just two ratios that equal to each other. So a fraction right here, a ratio equal to a ratio. The first one and the last one, the A and the D, are called the extremes. A and D are called the extremes. The ones going the other way, these are going to be called, the B and the C, are going to be called the means. And that matters because you're going to have something called the geometric mean, which is important and shows up a lot later. And if you cross multiply these, you're going to have two cross products. Those two cross products would be A times D right here. Oh, let me get my color coding right. A times D right here at the extremes, the first and the last one. And then the means, B times C, which is the middle two. So in a true proportion, those two amounts will be equal to each other. The extremes will equal the means. Again, all of this is vocab. We're not doing any problems here, but this vocab will show up later and be something you need to know. So for this next one, you're going to be completing each one of these proportions. So you're trying to make a connection between these numbers. This x is connected to this 6. This y is connected to this 7. If we cross multiply this, we would get 7x equals 6y. So you've got this new proportion down here where the x is over the y, and you're just trying to make that connection. So that x needs to be connected to the 6, the y needs to be connected to the 7. And you can check if you've got it right because you can cross multiply it and see if you get the same setup. Same two cross products. 7 times x ends up over here, y times 6 ends up over here at 6y. Same thing on this one. That y, look, the connection's right here. The y is connected to the 7, so y gets connected to the 7. The x gets connected to the 6. And if we cross multiply that, we would again get the cross products that are 7 times x, which is 7x. 6 times y is going to give you 6y over here. So just understand that a proportion can be rotated in different ways as long as you keep the relationship between the numbers the same. There are different ways to write the proportion and still be true. So the last thing we have is to solve these proportions. So when we solve a proportion, which you should have done in Algebra 1, you are going to cross multiply these proportions. You're going to multiply the 6 times everything up here, so I wrote it like distributive property. And then you have the 3 times the negative 26. If I distribute this across, 6 times 4x is going to give us 24x. And the 6 times the 5 is going to give us minus 30. On the other side, if we multiply the 3 times the negative 26, that's going to give us negative 78. From there, we need to add 30 to both sides. That's going to give us 24x is equal to negative 48. Divide both sides by 24, and x will equal negative 2. Now we will use those for other things and plug them back in word problems and things later, but for now, all it's doing here is asking you to solve for x. So for the last problem today, you're going to cross multiply the 7 times the x plus 4 down here, and the 9 times the x minus 1 over here. So 7 times x is going to be 7x. 7 times 4 is going to be 28. 9 times x is going to be 9x. 9 times 1 is going to be 9. You need all your variables to end up on one side, minus 7x minus 7x. That's going to make it 28 equals 2x minus 9. You're going to add 9. That makes it 37 is equal to 2x. When you divide both sides by 2, you do get a decimal, but guys, decimals are okay. 37 divided by 2 is 18.5 equals x. So that's our notes for the review of section 7.1. That's going to be things that we use going forward in this chapter, those ratios and proportions. Make sure you complete those before the next class, and I'll see you then, guys.